Hi class, I'm Professor Steele. Today we are looking at right triangle trigonometry. And why would we look at this? Well, I'm going to give you a kind of a scenario that you might be presented with. Perhaps you are looking at a tree who casts a shadow and you know the height of a person with the same shadow, and perhaps you're asked to find the angle. So we're going to introduce some terminology that you might be familiar with or heard in the past. We have similar triangles and we have congruency. So similar would be that we have the same shape but in different proportions. Congruent would be that they were equivalent. So when you look at this diagram, what seems to be congruent? Well, if you answered the angle, you're absolutely correct. The angle that is cast from the shadow of the tree and the shadow of the person are exactly the same. They're congruent. But then we have some similar triangles. We have a triangle here that is similar to the larger triangle created by the tree. So in order to solve a situation like that, we're going to go back to our unit circle, recalling that in our unit circle, we have our horizontal measurement created by the ray touching the arc of a circle. Horizontal measurement is our cosine theta, and our vertical measurement is our sine theta. So if we compare that to any triangle with the same angle, we can set up some proportions. We can see that sine of the angle divided by 1 is equivalent to this opposite side divided by the hypotenuse. Remember, this is all based on the fact that they have the same angle measurement. Similarly, cosine of the angle divided by 1 on our unit circle is equivalent to A, or adjacent side, divided by the hypotenuse. And tangent theta, which we know to be sine theta divided by cosine theta, if we look at the similar triangles, happens to be opposite over the adjacent side. So many of us mathematicians recall this as the mnemonic SOHCAHTOA, where sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent in a right angled triangle. Now, we need to talk about two other pieces of information in this scenario. We have what's called an angle of elevation and an angle of depression. So an angle of elevation would be from my eyes looking up, whereas an angle of depression would be from my eyes looking down. So depending on where we're located, if I'm standing here, then I have an angle of elevation looking up at the top of the tree. But if I was standing here and this was my sight, then I have an angle of depression. I'm just using the letter beta. So we have an angle of elevation and an angle of depression. Thanks for watching. We'll see you next time. Be sure to like and subscribe to EdVantage.